Hi folks, this is a quick tutorial on using the ratio test to find radius of convergence. Step 1. We're going to take the limit as n approaches infinity of the absolute value of a sub n plus 1 over the absolute value of a sub n. We are looking for absolute convergence. So we have the limit as n approaches infinity. Anytime we see an n, we will replace it with n plus 1. So we have n plus 1 times x to the n plus 1 over 10 to the n plus 1 all over. And then the denominator, we're going to replace n with n. So we're just writing what we see in the original expression. After we move around some terms, simplify, what we're going to get is we're going to get n plus 1 over n times 1/10 times x. So this is the next expression. Now, as n approaches infinity, n plus 1 over n is going to approach 1. And so what we end up having is basically, we have these absolute values. Forgot to put these absolute values in here. Okay, so every little piece have an absolute value. But of course, the n plus 1 over n approaches 1, so the absolute value doesn't really matter. And the 1/10 is just 1/10. So what we have now is we have absolute value of x over 10. And in order for this series to converge, this limit needs to be less than 1. And so what we're solving for right now is is for x. So we have absolute value of x is less than 10. And so that's the radius of convergence. Next, let's look at example B. We'll start with in the same way. Anytime we see an n, we will replace it with n plus 1. All over the original expression, because that would be a subscript n. Okay, now you can pause the video right now to simplify that on your own. But when you do, first of all, I need absolute value around these because I'm going to do absolute convergence. Okay, so now you can pause the video and try to simplify this yourself. Okay, all right. You should have this after simplifying this. Okay, now in order for the series to converge, this limit will need to be less than 1. Now once again, this part over here will approach 1. So then we have really just the absolute value of x plus 1 is less than 1. And right there, that's the radius of convergence. 1 is the radius of convergence. Here are 2 more examples. Part C. First, we have the sum, the series whose terms are represented by n factorial times x to the n power. So like before, we're going to replace n with n plus 1 and put absolute value around that. And then we will replace n with n, which is just to say a sub n. Okay, so this one simplifies like this. Now, n plus 1 factorial divided by n factorial is n plus 1. Okay, that's just something you should know. And then you have x power. Okay, so we have that. Now, the question is, what does this limit equal? Well, if you take a look at this right here, this part will approach infinity as n approaches infinity. What that means is that this limit is going to be infinity. So what that means is that this never converges. If it never converges, then the radius of convergence is 0. Now you can try example D on your own to see if a similar result occurs. So to recap what we did in 10.4 so far, we have something called a ratio test. For a series, if this limit is less than 1, then the series converges absolutely and therefore converges. If this limit is greater than 1, then the series diverges. If this limit here is equal to 1, then the test is inconclusive. And so we would have to use other tests to find out whether this series converges or not. We can also use the ratio test to find the radius of convergence by finding this limit and making it less than 1. So the examples earlier in this video show you how to do that. Bye-bye.